Hi, my name's Tim Yates, and I'm a maths teacher from Perth in Western Australia. And I've decided to create a video series about why I like maths so much and why I decided to become a maths teacher. Now, maths teachers don't just come out of a factory somewhere. We're people who've decided to become maths teachers and teach maths to people, which may sound weird to a lot of people. But I decided to become a maths teacher when I was 31 years old. Before that, I was an automation engineer. Before that, I was a help desk worker at an internet service provider. And before that, I delivered pizza for a living. And throughout all of that, and even today, I considered myself to be a gamer. And that means board games as well as video games. So here you can see my board game collection. And as far as video games go, this is my favorite video game right here, Super Smash Bros. And I have been playing this video game or versions of it for over 20 years. So I've been doing it for quite a long time. Now, some of you may wonder, what's all this got to do with maths? And as it turns out, it's got quite a lot. Games are full of maths. A lot of them are what happens when you take some maths and try and throw it at the wall and see what comes out. Geometry, algebra, finance, probability, these are scattered all the way through almost every game that exists, every good game anyway. And so in each of these videos, I'm going to be discussing a mathematical concept that I find interesting, and I'm going to teach you a game. And the first game I'm going to teach you is one called boxes. And there we go. So this is a typical boxes grid. It's got 4 dots across, 4 dots down, 16 dots in total. And the rules to boxes are simple. 2 players take a turn to draw one line at a time, either horizontally or vertically. So one player might decide to go like that, the other might go up there, and they take it in turns. But if you surround a box with 4 lines, like the blue player is about to here, you score a point and you get another turn on top of that. And whoever has the most points at the end of the game wins. It's a pretty basic game. A lot of you may have played it before. But what we're really interested in looking at now is what maths falls out of this. And that means, and when we're talking about maths, we're talking about patterns. So what patterns do we see when we start looking at the game of boxes in a little bit more detail? So now one of the things you should have seen just when I was mucking around, if you surround a box with 3 lines, so let's say we've got red, and then blue goes up here, and then red goes up here. If you surround a box with 3 lines, you're giving your opponent a free point. Blue goes there, gets a point, gets another turn. People are going to want to avoid that. So both players, it's not just you though, if you want to make sure that you never put a 3rd line around any box unless you absolutely have to. But your opponent is going to want to do the same thing. So where do we end up in a game like that? And I've got a little example here. And this is somewhere where we might end up after everyone's drawn all their lines. So blue and red have all drawn their different lines. Red is to play, they've got the next turn. And what's actually happened here is that around each of these boxes, there have been 2 lines drawn. And that is the case for every box that is on the board. They all have exactly 2 lines drawn around them. What that means is that a 3rd line is drawn, wherever it happens to be, the other person is going to get a point. So let's just draw that line back in there. Now it's red's turn. So red wants to, or has to, draw a line in here, but they don't want to give the other player a point or too many points, so they're going to go down here. Blue goes next. Blue gets that one. And then blue gets another turn. Blue's going to go down there. Red goes here, gets this one, and goes up here as an example. Then blue goes here, getting a point, here, getting a point, and has to start out this chain here. And that's very unfortunate for the blue player because red can now go 1, 2, 3, 4, 5, take all of these all in one group, and they win 6-3. So red wins in this particular situation, playing out in that particular way. Now blue didn't have to play like that. There may have been a way for blue to actually win from that situation. And that's something you might want to have a bit of a think about. But what ends up happening is that we start to create tunnels. Tunnels give one player a whole bunch of points at once. So here's an example of a really big tunnel made throughout the entire thing. It doesn't matter where blue puts a line. Let's say blue's to play next. Doesn't matter where blue puts a line. They could put it at the end here and then red will get all of these points there. But they could also put it right in the middle here. And what red could do is they could just go, yeah, 1, 2, 3, 4. Now they still get another turn. 5, 6, 7, 8, 9. And they have gotten themselves a flawless victory. So obviously blue wants to avoid that. And the interesting thing is that the only thing that stopped blue from being the one who got the flawless victory is that they just didn't happen to be the one, or they happened to be the one that got the turn at the wrong time. So, but sometimes there's more than one tunnel. And if there is more than one tunnel, when you end a tunnel, you're forced to start another one for your opponent. Can we control this a little bit better? So let's have a look at this situation. Blue is to play, and blue is just going to go like this. And red looks at this and realizes, oh wait, I could get this one, and this one, but then I'd be starting a thing here, and blue would end up getting all of these points. I don't want that to happen. So instead, I'm going to take this one because this is just 3 points. But instead, I'm going to cap off the end like that. What does that do? Well, now it's blue's turn. And blue goes, yep, 3 points. I'm going to take these ones. Nice. So blue has gotten 2 points at once. But blue doesn't get 2 extra turns when that happens. Blue only gets 1 extra turn. So blue's got to take an extra turn somewhere here. And blue's going to go down there. And then red gets to go and fill all of these in and then ends up getting the points all for themselves. And red wins 7-2. And that's the kind of thing that ends up happening in this game. You've got to be a little bit careful about what you do. You don't just want to take all the points that are right in front of you because you could trick your opponent into giving you more points, so long as you're a bit more careful about it. That's the kind of stuff that we start to see when we play a bit more of boxes. So we can control it a little bit better. And if we're careful, then we can go from a situation where it looks like we're going to lose into one where we can definitely win. There are lots of other tricks with this game. See if you can work them out. You don't always have to do a 4x4 box of grids though. Try other numbers and see what happens. You could try a 5x5, a 6x4, anything like that. Don't make it too big though, that gets a bit boring and we don't want to make a boring game. So, some of you may wonder, how can you play this game with your friends? Because it is a 2-player game, you need to be able to play it with people. It's a bit tough at the moment to get in with other people and play a board game, especially if you're socially isolating and all that. Now, in person, it's pretty easy. All you've got to do is you've got to hand your friend a grid of dots with a line drawn on it. But please don't do it while the teacher's talking. I'd hate to have to clamp down on anyone doing this instead of doing their proper lessons. But what about over the internet? So you can actually use a collaborative drawing tool to help you out with this. What you can do is you create basically an online page where you can both draw, you share the link with a friend, and you can get playing. And I found one online with a tiny bit of searching. I found one at aggie.io, aggie.io, and this is pretty well tailored for getting a quick little game of boxes up and running. And yeah, so happy gaming. I'd encourage you to check the game out, see what you enjoy about it. It's a fun little two-player game. It's really easy to play, and in the future, I'm going to try and show a bunch of other games that are a little bit like this, easy to play and quick to get going on. Now, while we're still in holidays in Western Australia, I'm going to be doing two more of these this week on Wednesday and on Friday. And then when school term comes back in, I'm going to try and do just one a week. And we're always going to be discussing a little maths concept. And then I'm going to show you how to play a game. So happy gaming and have a great day. Bye.